The topic in this lesson is going to be the sum and difference identities for sine and cosine, and then we'll talk about tangent when we get together in class. So we're going to start right off with the sum identity for cosine. So here he is, the cosine of x plus y. This is what I mean by the sum identity. We're going to break up an angle into a sum of two separate angles. The cosine of x plus y is equal to cosine x cosine y minus sine x sine y. So cosine is cosine cosine sine sine, and then the sine in the middle is going to be the opposite of what we have here. So we're going to start with this one. This is our first identity, and we're going to derive the others from this because this derivation is pretty simple. To get to cosine of x plus y, that derivation is pretty intense. It's shown in your book. But from here, if you can remember this one, we can get to the others. So the first thing I'm going to do, because we want to get to cosine of x minus y, which means I'm going to replace the positive y with a negative y. And by doing that, that lets me create the difference, a difference identity. So here's what it looks like now. The cosine of x minus y, because subtraction is the same as plus negative, you could use plus negative, I guess. Cosine of x minus y is equal to the cosine of x, and all I'm doing is replacing y with negative y in my original identity, sine of x and sine of negative y. So in the previous lesson we talked about the symmetric identities, and we're going to use those now because in the previous lesson we learned that the cosine of negative y is going to be the same as the cosine of y. The sine of negative y is going to be negative sine of y. So this is going to lead us to our next identity. The cosine, we'll do it in a couple steps though, of x minus y is equal to cosine of x, and then using that symmetric identity, cosine of y minus the sine of x times negative 1 times the sine of y. All I have left to do is to multiply this negative 1 by this one because that's really a plus negative, and this leads us to our second identity. The cosine of x minus y is equal to cosine x cosine y plus sine x sine y. So the only difference between the two is the operation in the middle. Those aren't too difficult to memorize. Our first one, the angle sum for cosine, and our second one, the angle difference for cosine. If you look at them, the only difference between them is the sum has subtraction and the difference has addition. Now we're going to work on getting the angle sum and difference identity for the sine function, starting with the cosine again. And here's how we shift over to sine. We know that the sine of theta is equal to the cosine of its complement. When you think of a right triangle, we know that sine and cosine for the sine of one is equal to the cosine of its complement. So symbolically, that means the sine of theta is equal to cosine of 90 minus theta. And the same way the cosine is equal to sine of 90 minus theta. So we're going to use this information here, starting with our angle sum, and come up with something for the sine of x plus y and the sine of x minus y. So for starters, let's replace theta with x plus y. So we're going to let theta be equal to x plus y, and let's see what we get here with sine of x plus y. So I'm going to take this guy and I'm going to replace the theta with the x plus y here, and then over here in parentheses because I have subtraction in front. So this is what we have, the sine of x plus y is equal to the cosine of 90 minus x plus y in parentheses because we have that subtraction sign. So now I can distribute here, and this is going to end up being the sine of x plus y. That's equal to the cosine of 90 minus x minus y. Alright, all I have to do here is regroup. I'm going to group the 90 minus x together, so that's one angle, and the minus y is going to be the other angle. So I'm really going to be grouping these two together. the sine of x plus y is equal to the cosine of, let me use brackets here, 90 minus x minus y. Alright, so it gets slightly more complicated here. This, I'm going to use the cosine difference identity. Here's my first angle, here's my second angle. And that's what we're going to use. Remember, the cosine difference identity is cosine, cosine plus sine, sine. So that's what we're going to do next. Alright, so here's what that looks like. The sine of x plus y is equal to the cosine of 90 minus x times the cosine of y plus the sine of 90 minus x times the sine of y. Now we go back to the original identities again. This is the complement of 90 minus x is the complement of angle x, and because of that I know that this is going to be equal to the sine of x, and the other one's going to be equal to the cosine of x. So finally we have our third identity, and it's the sine of x plus y is equal to the sine of x times the cosine of y plus the cosine of x times the sine of y. So when you're talking about the sine function, it's sine, cosine, cosine, sine. If it's addition here, it's going to be addition there. Finally, to get to the fourth one, I want to find the sine of x minus y. We're going to replace y with negative y again. So when we do that, we get sine of x minus y. And now that's going to be equal to sine of x cosine of negative y plus cosine of x times the sine of negative y. And remember, that's our symmetric identities. This one's going to be equal to cosine of y, this one's going to be equal to negative sine, so that's going to turn this addition into subtraction. So here's the fourth identity. The sine of x minus y is equal to the sine of x cosine of y minus the cosine of x sine of y. So there's our four identities, and what we're going to do next is just practice using them in different examples. Alright, when we do these problems, I want to remind you what it means to find the exact values. What that means is no decimals. So we're not going to put things in our calculator and round things with decimals. We want to leave things exact. We want to use special triangles. So that's our 30, 60, 90, and our 45 right triangle. And then we want to leave radicals exact. Don't put them in the calculator. I don't want a bunch of decimals. We leave it as a radical. And also when you do these problems, pay attention to quadrant signs, and again those special angles, so the reference angles and the quadrant signs. Alright, we're going to start off with finding the exact value of the sine of 285 degrees. So 285 is not one of our special angles, but we can find it by either adding or taking the sum or the difference of some of our other special angles. In this case, I'm going to use, if it's 285, that can be broken up into 240 plus 45. And those two have reference angles that are special angles. So that's what we're going to do. So I'm looking for the sine of 240 plus 45, which means I'm going to use my angle sum identity for sine, and I'm going to break it up. That's equivalent to the sine of 240 times the cosine of 45. Addition in between there, the cosine of 240 and the sine of 45. So when you do these problems, you have to take care of the quadrant sign for 240. 240 is in quadrant 3. So just a little side note here, this is quadrant 3, and its reference angle is going to be 60 degrees. So all that stuff we did in the last unit, it's all coming back. Okay, sine in quadrant 3 is going to be negative. So this value right here is equivalent to evaluating -1 times the sine of 60 degrees. And then the cosine of 45, that's a first quadrant angle, so we don't have to worry about sines there. Cosine of 240, again in the third quadrant, cosine is negative, so that's equivalent to evaluating the negative cosine of 60 degrees. And then times the sine of 45. From here, it's all just ratios. We're not doing decimals. We're not putting these in our calculator. The sine of 60 degrees is radical 3 over 2, so this is negative radical 3 over 2. The cosine of 45 is radical 2 over 2. The cosine of 60 is 1/2, so this is negative 1/2. And then the sine of 45 is radical 2 over 2. That's all you have to do, except now we're just going to simplify. We're going to multiply radicand by radicand, and then these will have the common denominator, so we'll write everything over a single denominator. Our final answer here is going to be negative radical 6 minus radical 2 over 4. So that's the basic process you're going to use to solve this type of example, where I'm given an angle and I need to break it up into two. All right, this is the other type of problem that you're going to see where we don't deal with the angles or reference angles. We only deal with the ratios. So given sine of alpha is 3 over 5 and cosine of beta is 12 over 13, so they're both positive, which should dictate which quadrant this is in, because sine and cosine are both positive only in the first quadrant. So we're going to deal with the first quadrant values here. I want to find the cosine of alpha plus beta. I'm still going to use the identity for the angle sum for cosine. So that's going to be cosine alpha, cosine beta, opposite sign for cosine, sine alpha, sine beta. Now what we have to do is find all the four ratios. I have two of them. I've got the sine of alpha and I've got the cosine of beta. So sine of alpha is 3 over 5. There's one of them. Cosine of beta is 12 over 13. Now I got to find the other two. I got to fill in this guy and this guy. Notice we're not evaluating the actual, we don't have angles that we're dealing with. I need to replace the entire function with the corresponding ratio. So that implies that we have to draw right triangles. If sine of alpha is 3 over 5, this is a 3, this is a 5, that's going to be 4. So cosine of alpha is going to be 4 over 5. Cosine of beta, that's an entirely separate triangle. If this is beta, this is 13, this is 12, that's another Pythagorean triple. You're going to find out that the other side is 5. So sine of beta is going to be 5 over 12. 5 over 13, I mean, not 5 over 12. Because what you should find, if you do this correctly, your denominators are going to be identical when you're done. So multiplying through, I get, looks like, what is that, 48 over 65 minus 15 over 65. So my final answer here is going to be 33 over 65. So those are the two types of problems you'll be doing with these, and we're going to be working a lot more in class. It is important that you memorize these four identities, and we're going to use them to look at tangent and some other identities in the future.